Okay, so today we're going to talk about inscribed angles and polygons. This is Unit 10.4 in IM2. Alright, so an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So you can see the blue inscribed angle over here, RQP. An arc that lies between two lines, rays, or segments is called an intercepted arc. So the red arc out here is the intercepted arc of RQP. Recall that a polygon is an inscribed polygon when all its vertices lie on the circle. Okay? So, the measure of an inscribed angle theorem is that the measure of an inscribed angle, this one, is 1/2 of the intercepted arc. So look here, we've got the measure of ADB is 1/2 the measure of AB. All right, so let's look at what we can do with that. So we want to find the measure of angle T. So angle T is this one right here, and we know that its intercepted arc is 48. So the measure of angle T is 1/2 the measure of arc RS. So it's 1/2 of 48. So the measure of angle T is 24 degrees. Okay, the next one they're asking you to find is the measure of QR. That is this one. So we don't have an arc intercepting that. So we have to use something else. So the first thing I notice is that RT is a diameter. Okay, so as soon as I notice that, and I see that angle QRT, so angle QRT is 50 degrees, and it intercepts arc QT, which is part of semicircle TQR, okay? And so since angle QRT is 50 degrees, QT is going to be QT is going to be twice that, which means it's 100 degrees. So that means this is 100 degrees. Since RT is a diameter, then QR would be 180 minus 100 degrees equals 80 degrees. And that is the answer for QR. So sometimes you have to get creative and work backwards to solve these things. Okay? All right, finding the measure of an intercepted arc. Find the measure of RS. So RS is this arc. And we can see right away that we have angle SUR intercepts arc RS. And so that would be twice as much as that arc. So that would be 62 degrees. So the measure of RS is 62 degrees. Okay, so then they also want you to find the measure of STR, angle STR. That's this one here. Well, notice that STR intercepts the same arc that angle SUR intercepted. So it would be the same angle measure, or it would be half of 62. So it is also 31 degrees. So the measure of angle STR is 31 degrees. So what do you notice about STR and RUS? They are congruent. So now let's look at this. We have the inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, so now they're showing you a different arc, but they intercept the same arc. Look at here, okay? They're intercepting the same arc, then the angles are congruent. And we just proved that right there. Okay, we didn't do it with a proof, but we proved it with an example. Okay? So, good job. Okay, so using inscribed polygons. Remember that a polygon is an inscribed polygon when all its vertices lie on a circle. Okay? The circle that contains the vertices is called a circumscribed circle. So here are some theorems. The inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter. Doesn't matter where it is, it's the diameter. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. Okay, then you have the inscribed quadrilateral theorem. If a quadrilateral can be inscribed in a circle, a quadrilateral can be inscribed in a circle if and only if its opposite sides are supplementary. Okay, so if it is inscribed, then the opposite sides are supplementary, and if its opposite sides are supplementary, then it is inscribed in the circle. Okay? Alrighty. So let's look at these to solve for these. So we have use the diagram to find the indicated measure. Again, push pause if you want to try these on your own, and let's get to them. So the measure of angle A. Well, we can see that the measure of angle A is to a diameter, so it is a right angle by the inscribed right triangle theorem. Okay, look at the measure of angle C. Okay, I used the triangle sum theorem, and I did 180 minus 28 minus 90, and I get the measure of angle C is 62 degrees. Now we're going to find BC, which is the diameter, and we're going to use the Pythagorean theorem. So we're going to go 3.9 squared plus 7.3 squared equals CB squared, and CB squared is approximately 8.3. Okay, then we have the measure of arc AC, that's this one, and the inscribed angle is 28, so we go 2 times 28, and that equals 56 degrees. Then we have arc AB. Remember that BC is a diameter, so we're going to go 180 minus 56, and that equals 124 degrees. So they want you to name two pairs of congruent angles here. So I'm going to show them to you, and there they are, because these angle BAC and angle BDC both intercept arc BC, and then angle BAC, I did it backwards. All right, and then ABD and ACD both intercept the same arc here, and so they are congruent. All right, using inscribed polygons, find the value of each variable. So I want to find the value of x. Since this is a diameter, then I know that this is 90 degrees. So 2x equals 90, so x equals 45. And that is by the inscribed right triangle theorem. Okay, for this one, I need to find this. So since DEFG is inscribed in a circle, we know that the opposite angles are supplementary. So 180 minus 120 equals y. So y equals 60 degrees. 180 minus 80 equals z. So z equals 100. Okay, so that is how you find those. All right, so find arc HML. That's this big one here, so let's highlight it so we can see. I think highlighters are really helpful in this. So HML, and then also arc HJL, which would be this one here, and I'll draw that on the outside. So first thing I notice by drawing those is I can see that those two are going to equal 360. So that's kind of nice. But the first thing I'm going to do is I'm going to find HML. And I know that the measure of HML is 2 times 109, because that's the arc that it that's the inscribed angle measure, okay? And that's the arc that it intercepts. So that means the measure of HML is 218 degrees. And we know that they also want, what do you notice about HJL and LKJ? They are both 109 degrees. They are congruent because they both intercept the same arc. And then we're going to find the measure of HJL, and HJL is 360 minus 218, and that's how you would find the measure of HJL. And you can go ahead and find that, okay? Because that's what's left over. All right, so given the measure of angle C, measure of angle C is 68 degrees. Find the measure of angle B. So they are both congruent because they intercept the same arc. So it is 68 degrees. Okay? Now there's one more problem here. This is number 7. And again, you're going to use that supplementary angle theorem. So you can work those out and push pause if you want to, but M is 180 minus 65, so M equals 115, N equals 100, with 180 minus 100, so N equals 80. So those aren't too difficult. Now, this next problem, I want you to think about. They're telling you that as you're taking your camera and it has a 90-degree field of vision and you want to photograph the front of the statue. So you stand at a location in which the front of the statue is all that appears. So here's the front of the statue, okay? Now, you want to change your location. Where else can you stand so that the front of the statue is all that appears in your camera's field of vision? So I want you to think about that for a sec and then go ahead and push. We're going to use the inscribed right triangle theorem to solve this. And we know, there you go, that if a right triangle is inscribed in a circle, then the hypotenuse of the triangle is the diameter. So this becomes the diameter of your circle, and you could move anywhere, diameter, you could move anywhere in the semicircle, and you will have 90-degree vision of that picture. So I thought that was kind of a cool one to put it into real terms. Okay, so here's your exit ticket for today. Notice the numbers are off, so I renumbered them, so pay attention to that. So for diagram 1, number 1 and 2 would be find x and y. Number 3 and 4 is find x and y for diagram 2. 5 and 6 are find x and y for diagram 3. And 7 and 8 are find x and y for diagram 4. And those will all be outlined on Edpuzzle. So good luck with that. Take care.